Hello all. So today we are going to say about the inversion of four-bar chain. So in the previous session we just seen what is meant by inversion. If we fixing the inversion of four-bar, so what are the types of mechanisms that we obtain and how does it work? So in this aspect we just seen in detail in our earlier session. So this session, which is also discuss about the continuation of that inversion of four-bar chain, but in detail of different mechanisms. So let me see, start with some example. For example, here you just see, because of the inversion of the four-bar chain, we will get that another mechanism is called oscillating cylinder engine. Generally, oscillating cylinder is nothing but crank has been rotated wherever the piston has been start reciprocating in oscillatory direction. We know that the piston is reciprocating and the crank has been rotating, but here the cylinder arrangement will start to oscillating because of the piston motion. So that is what you call that oscillatory cylinder motion. So instead they will fix their baseline here, whatever the things that you have seen in your screen. It is used to convert that reciprocating to rotary, but in terms of with the help of connecting rod. So that is what the piston rod has been highlighted, and wherever the crank make a rotation in opposite direction. So the another example for this piston rod fixing, here we just taken another example is a multi-cylinder radial IC engine. So normally we used to see this kind of engine in advanced automobiles, which we have seen in our day-to-day life. Since we already, there is so many engines which has been used in our automobile, but at the same time that multi-cylinder has been adopted with the help of type of V engine, or it may be an I-shaped engine, or it may be an alignment of genome engine. It is based upon totally the mechanism point of view, which has fixed any one of the link so that it can produce that motion. So that is what we call that geometrically it having a three sides, the values which has been mentioned in this diagram. So this has been used to modify and make a constraint tool to form a structure, and it can move relative to each other. So the another one example is about genome engine. So generally genome engine is nothing but it is an rotary kind of engine, which means the pistons has been, multi pistons has been there, but it is in circular shape, and the motion will take place like an oscillatory motion. When it traces the curve, it forms like an elliptical curve. So that is why it is called genome engine. Normally it was not in use because of that difficulty of achieving that combustion. So that is why it has been stopped at some point. So that is why it is called it as a rotary internal combustion engine. Sometimes it has been displayed as a genome, which means it has been exhibitionally it has been displayed, but it was not in use. So there is a huge amount of torque issues which has been produced in this kind of engines. That is why it was not in use. So we know that this is the shaper machine. We know that how the shaper machine has been worked. Generally, shaper means that tool has been reciprocated, but for the reciprocation, how the tool has been reciprocated and how it can make the quick return. So what mechanism which has been used in the shaper machine here? Normally we use it to adopt that crank and slaughter lever especially for this shaper machine. Here the workpiece doesn't get moved, but wherever the tool has been reciprocated linearly, either in positive x direction or negative x direction with respect to that crank and slaughter lever. So this crank and slaughter lever will make a quick rotation when it reverses back, which means it refers there is a good surface finish when there is a short return takes place. And when there is a mutual rotation or mutual movement takes place, what happened that a huge amount of material has been removed and the surface has achieved precise finishing, and so that the return will take place in very short time and also without any time deflection in this quick return mechanism. So that is why we used this mechanism for shaper machine. But the same thing it has been adopted in planer, but instead of this mechanism we used to take it as an slotted and lever mechanism. Here crank and slotted mechanism, where in that case we are using slotted and lever mechanism. Their motion has been little bit varied because of that quick inversion. Here they are in planning machine we used to take that workpiece as make a movement, or wherever the tool is making as a stationary. So that is why the mechanical inversion has been varied with respect to the application usage. Okay, so with this I just go and wind up, and we will continue next session. Thank you so much.